Welcome to Climate Watch. And today I'm honored to have Professor Wang Can from Tsinghua University to join me on the show. Professor Wang Can is the chair professor of the School of Environment at Tsinghua University. He's also been in the field of climate change economics and policies for decades and also involved in UN-led climate negotiations for over 10 years. So he's a close watcher of China's evolving green industries. And so welcome today, Professor, to join us on Climate Watch.
Thank you.
And today we are going to talk about Professor Wang and his team at the School of Environment and also at Tsinghua Institute of Carbon Neutrality. They launch a report every year to track the global progress of carbon neutrality. And in this year, after taking a close look at where things stand toward nowadays, and how would you say, what are the mainstream technologies on the market in the world at the moment?
Well, I think it's a very important starting point. When we talk about mainstream technology, we are referring to those that are already widely adopted, cost-effective, and playing a central role in reducing CO2 emissions across major sectors. So on the top of the list are renewable energy technologies, especially wind and solar power. These have become the backbone of global decarbonization efforts. In fact, China is leading the way. Last year alone, China accounted for about 2/3 of the world's new renewable energy capacity. So that's a remarkable contribution to global climate targets. Another key area is electric vehicles. EVs are no longer just an emerging trend. They are now mainstreaming in many markets. China, again, is setting the pace here, both in terms of manufacturing and domestic adoption. What's happening in China's EV ecosystem actually is transforming the global auto industry. And in the building sector, heat pumps are increasingly replacing traditional gas boilers. They are highly efficient, and when powered by clean electricity, they significantly reduce emissions from heating and cooling. We see strong uptake in Europe and also an increasing interest in Asia as well. Another technology like battery energy storage is also rapidly moving into mainstream. As more and more solar and wind under the grid, storage is crucial to ensure the reliability and stability. So, in this area, China is also a global leader in battery manufacturing and deployment. Well, and we shouldn't forget energy efficiency, which is often overlooked. But it's one of the fastest and the most cost-effective ways to cut emissions. Whether it's upgrading industrial equipment or improving installations in buildings, efficiency is the foundation of any serious climate strategy.
Well, I'm very curious about this part, about energy efficiency. Can you give us some examples about what kind of technologies are we referring to when we're talking about energy efficiency?
Well, like this building, the School of Environment at Tsinghua University, it's an energy efficient building. We have very advanced insulation material for the whole building, and we have advanced control system for the cooling system. And this building was built in 20 years ago, but at that moment we used many solar PVs you could see outside. So it's a clean energy supplied building. So high efficiency for cooling and heating in the building, and also using the new and renewable energy That means the building could, will have very relatively low CO2 emissions.
So when we're talking about energy efficiency, it's not about one technology. It's more of a systematic changes to current using different technologies.
That's true. In many sectors, you could have the chances to deploy energy efficient options. So I just mentioned the building sector, and if we look at transportation, the same, and especially for the industry sectors. So it's a very broad technology area.
And when we're talking about, I know when we are talking about decarbonization and the use of these technologies, the ultimate goal is to reach carbon neutrality. But what about short-term goals? And because when we are talking about goals, different countries have like different agendas and different plans. And why are we seeing these differences?
Well, it's a great question. I have to say it's important to recognize that the decarbonization is both a global race against time and a nationally tailored journey. So in the short term, most countries are focused on hitting 2030 targets, like tripling global renewable energy capacity, doubling energy efficiency improvement, scaling up clean hydrogen. So all these are short-term targets. Based on our latest analysis, we are only about 1% to 40% of the way there, depending on the technology. So the next 5 years or 10 years, absolutely it's very important, critical for achieving the carbon neutral targets. For the long term, we know nearly all major economies have pledged net zero emissions by mid-century, 2050. And for China, we pledged it before 2060. But the pathways vary. China, for instance, has already achieved its 2030 targets, the renewable targets. So it's 6 years earlier. But for US, it's targeting a 100% clean power system by 2035. For EU, its near-term targets is 55% CO2 reductions by 2030. So we see it's a quite different short-term, different ways, but we see the convergence on the long-term targets.
And also countries are taking like different pathways and strategies really when we're talking about how to reach the ultimate carbon neutral goals. And when it comes to short-term goals, as you mentioned, China was planning on dual carbon goals, reaching carbon peak before 2030 and realizing carbon neutral before 2060, as you mentioned. And so why are we seeing these differences?
Well, I think the difference is to a large extent it's due to the differences in resources, endowment, development stages, economic structure, also policy preferences. China, for instance, is betting big on the scale and innovation. It's rapidly expanding solar, wind, battery, EVs, not only to decarbonize its own economy, but also bring costs down for the rest of the world. So this manufacturing scale is critical for making clean technology accessible globally. And in the United States and some other OECD countries outside the EU, the strategy focuses more on blue hydrogen and large CCUS hubs, CCUS carbon capture, usage and storage, and to decarbonize hard-to-abate sectors like steel and cement. This approach actually also helps extend the use of existing fossil fuel infrastructure. So that's you can see why some countries are focused on different technologies. I can also mention some other developing countries like Brazil, Indonesia, they usually focus on hydropower, sustainable biofuels, and also forest-based sinks, so which have quite strong implications for the rural development, land use, energy access. So you can see the local priorities behind the climate targets.
So when looking at these different scenarios, different pathways and different goals, whether it be China, the US, or other OECD countries or even developing countries, are you confident that they are going to reaching these goals? Or do you share some of the urgent calls globally about we need to act more, we need more technologies, and we need to move fast?
Well, actually, I absolutely share that sense of urgency. The message is very clear. We have many of the technologies we need, but we are not deploying them fast enough to meet our climate targets. So our latest data shows that across 7 key technologies like renewable, EVs, clean hydrogen, CCUS, deployment levels are only 1% to 40% of what's needed. If we continued at last year's pace, only forest carbon sinks are on track. If we average the past decade, maybe EVs and hydrogen can catch up. But renewables, energy efficiency, biofuels, all need scale dramatically. CCUS, for example, by almost 8 times. So yes, we urgently need faster deployment, not just innovation. So the technology exists, but we now need the policies, investment, political will to scale them up.
That's very interesting, and I want to break it down technology by technology. As you mentioned, renewable, we also need to move faster when it comes to deployment of renewable energy. And you also mentioned, for example, like China is leading in this field, especially in solar and wind. So for the prices, for instance, for installing solar panels are extremely low these past several years. And what is sort of stopping them or slowing down the paces?
Well, I think it's a number of reasons. Although we see the low prices, observing the energy or electricity producing prices from solar, wind, or renewable energy, but the upfront cost is still high. We need some corresponding infrastructure like storage. If we consider all this together, the upfront cost is pretty high for this technology. We need more dramatic, enhanced capacity for electricity storage for the grid level. So I think it's a mix of some barriers behind this phenomenon, like technical, financial, also political. And all these barriers, they often reinforce each other. So as I mentioned, the financially advanced technology, many of them are still stuck in the pilot stage. And on the other side, many developing countries, they usually have difficulty to access long-term green finance. And for politically, we are seeing new clean tech tariffs. And in China, for example, local content rules, and also some uncertain carbon pricing. So all these will raise investment risk for the carbon neutral technologies scaling up.
Mm-hmm. And how about for hydrogen? I think since later last year, there are a lot of talks around hydrogen, not only here in China, but globally. People are betting high on the future of hydrogen. I'm also curious about your take on this particular energy?
We usually classify hydrogen into several types. We call it gray hydrogen, blue hydrogen, green hydrogen. Traditional hydrogen is be called gray hydrogen from the fossil fuel. For the blue hydrogen, it's hydrogen produced from fossil fuel plus carbon capture and storage. So hydrogen plus CCS means carbon neutral hydrogen. But because it's from fossil fuel, it is called blue hydrogen. For green hydrogen, it's come from clean technology, like produced or electrified from solar or wind power, and then also plus CCS. Then it's a negative emission hydrogen, so it's we call it green hydrogen. For the future, to achieving carbon neutral targets, the central role to be played will be green hydrogen. But at the current stage, we see in this technology, if it is deployed at a large scale, then again, we meet the high upfront cost. We also meet the premature technology because we need a technology trend to produce large-scale green hydrogen.
So it still comes down to costs.
That's true. That's true.
So financing is kind of a key bottleneck for a lot of these technologies to be further scaling up.
Yeah, financing and also the infrastructure. If we want to have large-scale green hydrogen, we need much more green power generation. We need hydrogen pipelines, and we need many enormous hydrogen equipment, production equipment, and deployment equipment like hydrogen to be applied in transportation, in building, in industry sector. So all these need a number of new equipment. So this is, we call it a technology ecosystem. And if we look at this ecosystem, then green hydrogen, we say it's still at a very early stage, pretty much.
So right now we are talking about a lot of gaps in decarbonization technologies. And I'm also wondering, do you have like any innovation or technological breakthroughs in recent years that's sort of giving you the hope or really caught your eye or got you excited, really excited in the field of, especially technology-wise?
We just look back in 2024. It's really exciting me, especially for renewable energy. So it's not a very new topic. But if we look at the data, the global renewable power capacity hit a record 585 gigawatts, the highest ever added in a single year. So what's even more encouraging is what that means going forward. And looking at that data, our analysis also shows that if this pace continues, we could reach over 9,300 gigawatts of renewable energy capacity by 2030. That's 2.77 times the 2022 level. And if without the 2024 surge, we'd only be on track for around 7,300 gigawatt. So this record year has really shifted the trajectory, and this is a very important breakthrough. We previously viewed renewable energy pretty high cost, but from the progress in last year, we see it's very competent with traditional fossil fuels.
Do you think that, especially when it comes to solar and wind power, that the changes happen, they are sort of the game changer when we're talking about decarbonization, and the reason, the fact that they're so cheap right now and so accessible right now are giving the world a sort of confidence boost to realizing their carbon neutrality goals.
Yeah, that's true. So this also tells us something important. So while the message is, while some technology are still lagging, the system as a whole is transforming, and we see it's entering an accelerating phase of transformation. So it's a reason for cautious optimism for the future, and a sign that when policy, technology, or investment align together, progress can come faster than we think.
What are the next big technology coming after solar and wind power, probably, that can be more accessible, can be this cheap, can be really exciting?
Well, one area I think still will attract me very much and deserves more attention. And also, in our report, we paid new attention in this year is artificial intelligence and digital technology. We call it AI, where we often, usually focusing on the hardware like wind turbine, solar panels, or hydrogen equipment. AI is becoming the intelligence layer that ties this system together and make them work efficiently at scale. So why AI is as the answer to your question, it's because the carbon neutral transition is highly complex. It spans from energy system, industry, building, transportation, nature-based solutions. All these are nonlinear dynamic systems, and that traditional tools struggle to manage. But AI brings, capacity to forecasting, optimization, and the real-time decision-making that are vital to managing this complexity.
Do you have any examples in how AI or digital technologies are helping the decarbonization?
Well, from academic side, we see lots of new breakthroughs, like using AI to select the site, or to monitoring the system, or evaluate the performance of the emerging technologies like hydrogen or CCUS. So it's a very advanced stage using AI to doing this. If without AI, then the process maybe take even longer time. But with AI, we see the progress within a short term. Another type of example is, for example, for the renewable energy for the future, AI can enable high-resolution weather forecasting. AI can optimize grid dispatch. AI can also, optimize the storage, energy storage. So for the grid, the renewable energy supply feeding to the grid, then the grid dispatch, then to the end users. All this system with AI could be, optimized to enable absorb more capacity of renewable energy power generation.
So AI can be a very helpful assistant to a lot of the systems or upgrading or decarbonization efforts. And another area I want to check with you is about particular here in China. And I'm curious, how would you describe China's overall layout of decarbonization technology so far?
China is pursuing what you could call it top-down system-level strategy for decarbonization. So it starts with a 1+N policy framework, a national climate roadmap supported by sector-specific plans and also provincial level plans. So this is also backed by a rapidly expanding national carbon market, which is guiding the emission cuts. So this is, I think, it's a whole system for the decarbonization. For example, in power sector, we could see more specifically. As I said before, China is moving at a record speed, adding 377 gigawatts of new wind and solar just in 2024. That's more than half of the global total. And it's not just about scale, it's about integration. Ultra-high voltage lines move the clean power from the west to eastern cities, and AI tools, as you mentioned, help optimize generation and grid dispatch in real time. And furthermore, China's strength in manufacturing solar panels, barriers, and EVs keep costs down, both domestically and globally. So look specifically into China's practice. We really see a strategy that combines manufacturing scale, infrastructure, and technology development to drive deep decarbonization across the system. So it's a nationwide systematic practice.
And I think a lot of people also agree with you when it comes to China's advantages in decarbonization, the top-down level design, policy design, and also the capacity of manufacturing and the whole industrial system is the advantages that China has. But in your eyes, where do you think China still needs to catch up?
Well, China is leading in many areas like solar, wind, we said, EVs. There are still, I think, key gaps to address. One major area is the heavy industry. As you know, in China we have cement, steel, chemical. So for these heavy industries, especially hydrogen-based steel making and large-scale carbon capture and storage, we call it CCUS, it's a shortage so far in China. Right now, China's total CCUS capacity is only around 10 million tons of CO2 per year, which is far below what's needed for deep decarbonization of cement, steel, and chemical industry sectors. Another challenge is grid flexibility and long-duration energy storage. As the renewable generation grows rapidly, we are seeing rising level of curtailment, meaning clean energy that provided, produced, but not used because the grid or storage can't absorb it fast enough. So this is another area of shortage. So we see while the clean energy supply is expanding impressively, integration and decarbonizing industry are the next frontier where China will need to scale up quickly.
And where do you think the reasons are? Is it because of the technological bottlenecks, or China also needs to catch up in terms of financing or policy making?
Well, I think both sides. One side is China have relatively large amount of heavy industry comparing with other economy, especially the large scale economy. On the other side, the competence or competitiveness of this type of industry is pretty, relatively low. So we have fewer, comparing with other sectors, have fewer revenues for the technology innovation. I think then that's one side is technology difficulty, another side is financial availability for this type of sectors.
And also you mentioned, for example, in OECD countries like the United States, they're also quite emphasizing a lot of preferential policies or I'm not sure about funds, but a lot of attentions are going into hydrogen, are going into CCUS. Are you hopeful that probably some of the breakthroughs can be witnessed in those countries?
Yeah, we can see carbon neutral transition. It's not relying on only one technology. It's a systematic change. And we see different countries pay different attention to different technology. That means we need cooperation. So international cooperation to advance systematic technology improvement. So it's not relying on only one technology, but we need a package of all this technology, combine them together. So in some circumstances, renewable energy plays an important role, but in the other economy or structure, maybe, as you mentioned, hydrogen or CCUS will be necessary. So really, it's international cooperation. It's important, and cooperation in terms of financial support, technology development, jointly development, technology sharing, or international market. All this will benefit the global climate target achievements.
So looking ahead, you don't think we shouldn't relying on specific technologies, either it be one or multiple, for our future decarbonization efforts, but instead you believe that we should be placing our hopes on a collective efforts. But how do you evaluate the current stage when it comes to international cooperation? I know there are a lot of things happening, a lot of voices. Some are positive, some are sort of doomist, some still believes in going ahead with climate goals. Some are start to stepping back when it comes to climate policies. It's a very complex situation that we're in globally.
That's true, and I just mentioned at one point, like politically we are seeing new clean tech tariff, and our analysis shows that rising tariff could increase global solar and wind investment costs by 6% and 3% respectively, creating a $130 billion funding gap for meeting 2030 targets. So this is one example in the international circumstances. Actually, it's not in favor for global climate change and transition. But that means we need integrated solution. The blended finance, foster faster permitting and clear long-term policies. And without this, progress will keep falling short of our ambition. That's true. But another point I'd like to to say it's the most important for the future or the foundation is confidence in the long-term direction, even when short-term progress feels slow. But we need confidence for this. We have seen this in many areas like solar, wind, or EVs, one thing as a niche, but now scaling at a record pace. So the emerging solution for the future, like what we mentioned, hydrogen or CCUS, are entering a critical phase driven by rising carbon prices or strong industrial policies. And also we met some international difficulties, international trade or tariff difficulties. But confidence is important to ensure they will happen. So confidence isn't a blind optimism. It's built on a clear signal, aligned system, and the belief that transformation is not only possible, but inevitable.
So are you personally, are yourself very confident in the long-term goals?
Yes, as I mentioned, it's because we see a lot of signals. We see a number of countries are building an enabling environment or ecosystem for this transition, like in China. And more importantly, we see this transformation or this carbon neutral transition is necessary for combating climate change. So it's possible and it's necessary. Then we have to be confident for this long-term future.
So before we close off, I do want to check with you, were you in Copenhagen when that negotiations?
Yes, I was.
And then were you in Paris when that?
I was in Copenhagen and in Paris. After Paris, I moved step out the negotiation process.
So for you, from your perspective, the current either tariffs or the current stepping back of certain countries is sort of a short-term obstacles that will emerge somewhere along the way, just like what happened in Copenhagen and then in Paris.
Yeah, somehow if we look at the changes, the history, we see some frustration move back and forth on this process. But I think the grand trend or the global trend for carbon neutral transition doesn't change. Even in the United States, we see the federal policy changes, but the industry side, like renewable energy, like EV sector, they developed very well. So this grand trend doesn't change, and I see the changes step by step from negotiation process to the domestic actions. Now we are in the stage of post-Paris Agreement. It's a national determined contribution model for the global action. And then from our report, the annual assessment report of global carbon neutral progress, we do see more and more countries are taking actions domestically to fulfill the global requirement. Some directly from Paris Agreement, some are not, but we see the real change on the ground.
So towards decarbonization, towards carbon neutrality is sort of unstoppable currently.
I think so.
Thank you, Professor Wang.
This is CGTN Radio. Hear the difference.